Hello there. Welcome to Algebra Chapter 8, Section 2. We're going to begin multiplication and factoring here. On this lesson, I don't have a template for you. I will offer the three-column template in class if you want it. If you would like to just take notes your own style on your own notebook paper with this, I'm fine. There's just a lot of material here to get down, and I just couldn't find a template I was really happy about. So we're just going to have to do this the old-fashioned way and do the best you can, but get down, especially when I say write this down, make sure you have those things down. There's quite a bit of material here in 8.2. Factoring is a pretty difficult section that we cover here in algebra. So let's just roll right into things here. We're going to begin by reviewing how to get a greatest common factor. Some of this you'll be able to do in your head, and hopefully the more we do with the basic factoring of things, the easier it becomes for us here. But I do want you to write this down for us. I've got two examples here. I'm just going to ask you to write down the 18 and 12 one, and then we'll do the second one in our head. One way to do factoring that you should have learned in previous years is to do this thing called prime factorization, where you ask yourself, how could I multiply to get 18? And there's several ways. I think I'll do, how about 6 times 3? 6 times 3 is 18. So we write down 6 times 3, and we ask ourselves if one of these numbers is prime. This one is prime, so I keep that, and I continue going with the 6 because 6 is composite. It's not prime. 6 can be multiplied to 3 times 3. No, it's not 3 times 3. It's 3 times 2. Apparently, I can't multiply. I can do algebra. I just can't multiply, I guess. All right, so we have a 3 times 2, and I'm going to circle those two because they're prime. So basically, these are called prime factors. 2 times 3 times 3. Those are all prime numbers that multiply back to get 18. Now, this is really review for us here. It's something you did last year. If we did the same thing with 12 to find the prime factorization, is what this is called, we could get 12 by going 4 times 3. There's a prime number, so I circle that one. This one is not prime, so I'm going to continue going, and that could be 2 times 2, and I circle that 2 times 2. So 12 comes out to be 2 times 2 times 3. Now, before I go on, this one right here, remember that was 18, right? And there, if you see, if you multiply those numbers, 2 times 3 is 6, 6 times 3 is 18. These are prime numbers that would multiply back to the original number. Well, one thing we can do now with those is we can ask ourselves, well, of these numbers, which ones do they have in common? Well, they both have a 2, and they both have a 3, but they don't have a second 3, and they don't have a second 2. So those numbers multiplied together will give you the greatest common factor. Now, I know you can do that in your head. I sure hope you can, because it'll make our life a lot easier if you can. But that's an old-fashioned way to do that. There could be a time when you might need to use that if the numbers got kind of large. All right, on the second one, we won't go through that whole thing here, but take a look at 24 and 28. If I asked you what's the largest factor they have in common, hopefully you could figure out in your head, well, 2 is a factor, but there's a larger one, isn't there? 4. 4 is the biggest number that goes into both 24 and 28. I don't think there's another one. So that's the greatest common factor, and you have to be able to figure that in your head, hopefully quickly, to begin factoring, is to identify greatest common factors in two numbers. Well, part of the reason I showed you this is because we're going to move on to factoring monomials, which lead us to polynomials. So I have 3 examples here, and I want to show you the first one. These have a greatest common factor, x to the 4th and x to the 6th. Now, if we were to actually do the prime factorization of x to the 4th, well, we could say x to the 4th is x squared times x squared. And if we expanded that, it would be 4x's, right? X times x times x times x. That is x to the 4th. So you kind of hopefully can see where we're going with this. If I did the same thing with x to the 6th, I would have x times x times x 6 times, right? So go ahead and write that out on this one. 1, 2, 3, 4, 5, 6. Okay, on this example here. And then if we ask ourselves, well, what do they have in common? Let me scroll up a little bit so you can get it all on the screen. This has 4 x's in common with this. So 4 of them are in common, but there are 2 that has two extra ones that aren't included in that one, so that x to the fourth is the smaller number. So what we can say is that the greatest common factor of x to the fourth and x to the sixth is x to the fourth. Okay, so actually with monomials, it's really easy. If you haven't figured it out already, if you have two variables that are the same, you basically take the smaller exponent, because that is going to have four factors in common, and that is like that every time. So if we go to the middle one here, we don't have to write this whole thing out. We shouldn't need to do that. We should be able to go on faster than that. What you do have to do is figure out, well, I know that I need to figure out the greatest common factor of 8 and 10, and let's see, I believe 8 is divisible by 4, but 10 is not, so it looks like it's going to be 2. 2 is the greatest number that goes into 8 and 10. So then you have to consider the variable. You have x squared and x to the third. What do you think that is? It's x squared, because that has two factors of x, and that has two factors of x and one extra one, but that's the only one they have in common. So that is the greatest common factor of those two, 2x squared. So it's really not that difficult for us if we think about it. Why don't you hit pause and see if you can answer this question before I reveal the answer. 20x cubed, 35x to the fifth, 40x. Go ahead, hit pause, and then I'll be right back to tell you the answer. Okay, if you're back, hopefully you've got a guess. By now you had to figure out what's the largest number that goes into all three. Hopefully you saw that. I believe that's 5. And then the most exponents that all three of them have in common is x. The answer is 5x. That's the greatest common factor. Hopefully that worked out for you. Okay, so that's the background. Now all that information is really background to where we are going. What we are going to be doing is finding factoring polynomials, which basically, this is important to write down right here. Factoring a polynomial, hit pause if you have to, but right here, factoring a polynomial is to do the opposite process of multiplication. Okay, so it's kind of like you're doing multiplication backwards, or obviously division is going to be involved in this. But what we're looking at, we're going to be looking at polynomials instead of just numbers that are divided. Let's take a look at what we mean. Now here, this is more review, because it's really important that you see where this comes from. Let's consider the distributive property, which we've been doing a long time this year, and then the multiplying the powers we did in the last chapter. If I asked you to multiply, this does need to be written down, please, this example. If I asked you to multiply 3x to the fourth times the quantity negative 2x to the fourth minus 6x cubed plus 3x, what we would do is we would have to take this term times this term right here. Now you see there's a lot of algebra that you've learned this year happening here. You have 3x to the fourth times negative 2x to the fourth. So you'd go 3 times negative 2 would be negative 6. All right, you'd have negative 6, and then you'd have x to the fourth. Remember what happens when you take a variable with the same base? You add the exponents. That would be negative 6x to the 8th, and then you would continue doing that. That would then be minus, and then you'd go 6 times 3 is 18, and you'd add the exponents there, and you'd do the same thing with the 3, and hopefully you'd come out with this answer. There's 3 times negative 6, it's 18x to the 7th. 3x to the fourth times 3 is 9, that's x to the fourth, and that's, you just bring those signs down there to match, and you have it right there. So that's the beginning of where we are. All right, now I'll tell you this, foreshadowing what you're going to see next. This form right here, the question, that is actually the factored form. Okay, this form here is simplified. So what we're going to be doing, and starting in the next video here, is the question will actually be this. Okay, and the answer will be that which we started with, and that all has to do with being able to recognize factors, common factors between terms like this. So I have to stop this one as I'm running up on 10 minutes, give you a break, let you drain your brain a little bit, and when you come back to the next video, I'm going to show you how to begin factoring a polynomial.